Acids, bases, week 3. I feel like lots of people, you might have heard of something being acidic. That's a pretty thrown around word, but I feel like lots of people don't understand what that means. So we're gonna talk about that right now. So acid and bases and the pH scale are talking about the amount of protons, positive ions, in a substance, because we talked about in the last video there could be ions, and hydrogen is an interesting element in the fact that it has one proton and one electron, but when chemical reactions happen, it has a tendency to pull the electron off of it, leaving it a positive ion with no electrons. That makes it interesting in how it works, and that's what pH is measuring. Basically, the lower the pH, the more hydrogen ions are in it. I know that's a little counteractive, but I didn't make it, so we're just going to talk about it. So if something is acidic, low on the pH scale, it's going to have a lot more of these. And well, let's say like something like citric acid, also known as like orange juice, lemonade. It's gonna be acidic. It's gonna have a lot of more of these. On the pH scale, it's kind of like a 2 or 3, right? On the pH scale, and that is basically showing that there's more acids within. There's a really large equation that actually kind of shows this, but basically it just means there's a lot of hydrogen ions. You don't want to confuse you any more or less, but something that's lacking hydrogen ions, because there's also the opposite, is like bleaches, things like that. It's low in H+, and they have very similar properties when you get to either low amounts or high amounts of H+ within a substance. But bleach is about like a 10 to 12 on the pH scale. It goes to 14. It goes from like 0 to 1 to 14. And something that kind of shows the balance is like water is at like a 7, like middle ground, nothing happens, and that is the pH scale in a very dumbed down version. But it shows that as things are lacking or have too much hydrogen ions, or positive or negative, it turns into something that is very reactive. Like acids in general, like if you put like citric acid like in your mouth, it definitely kind of tingles, really sour, whereas water does not do that. And if you put bleach on anything, it turns it white. Like it's taking away, like it's so negative, it's taking away all the positive from the stain, and it's leaving it white. It's taking away the ink, it's taking away everything. It's just really basic. Whereas acidity does the opposite, but the same. And to the eye, it kind of looks similar, right? It's, instead of taking away the positive, it's giving, right? That something is more basic than it is going to give protons, and that kind of shows the different but destructive properties of both sides of the pH scale. And it's really important when it comes to like your body, is your body's going to want to not have really basic or really acidic properties. Like your stomach's a little more acidic than your intestines, and there's going to be things that change to make sure that you're not eating yourself, because that is not a good thing when it comes to living. There's also hydrogen bonds are kind of similar in the fact, but so there's water. H2O is the chemical name for it, which just means there's one oxygen and two hydrogens. And we talked about already that hydrogen only has one electron. So the electrons are going to be pulled towards the oxygen, leaving this side more negative and this side more positive. And we know with magnets that positive and negative attract. So let's say there's another water right here. Well, this is positive, they're going to be attracted together. And that's what kind of makes water be collective together. If you see like the skin of water and the way it sticks together is because of these hydrogen bonds. They're not technically bonded together, through covalent bonds or ion bonds, but they're magnetically together because when you start adding a lot of waters and oxygens attached to all these hydrogens, and we know that there's a ton of these molecules in one little drop of water, that they're going to tend to stay together. And that is how hydrogen bonds stick together. That's how water kind of has interesting properties compared to maybe other liquid substances that you've seen, but they are very cohesive together, and they actually work a lot within the body to help things stay together and break things apart. And that is hydrogen bonds.